Hello. Today we're going to be talking about linear functions and functions in general. So we're going to do an activity here using this flow chart. So I want you to think of a number. It can be any number. I'm going to say 6. Okay, you can say whatever you want. I'm going to take my number and I'm going to multiply it by 9. So when I do that, I get 54. Then what I'm going to do is I'm going to subtract my original number to get 48 and divide that number by 4 and I get 12. So I plugged in 6 and I got out 12. Let's try it with another number. Let's do 4. Multiply that number by 9 gives us 36. Subtract your original number gives us 32. And divide by 4 gives us 8. So if I plug in 4, I get 8. If I plug in 5, I get 10. If I plug in -6, I get -12. The whole idea here is that all of these numbers, while we're plugging in different numbers and getting different numbers out, there is a special relationship here. If you take the x value and compare it to the y value, the input, and compare it to the output is exactly twice as much. So the output is twice the input. So it doesn't matter what we plug in, we're always going to get something that's twice that number out. This idea of plugging something in and doing something to the number and then getting something else out is what a function is. A function takes an input, does something to it, and gives you an output. So we're going to be dealing with function notation. So what happens is you're used to seeing an equation that looks like this. This was from our last unit. It's slope-intercept form. You're used to saying, okay, 2 comma 5 means, oh, I guess it wouldn't be 5. But if I plugged in 2 here, I would actually get 10 back out. So x is your input, y is your output. What we're going to do now is we're going to take our y value, and instead of writing y, we're going to change it to f of x. Okay? So f is going to be the name of the function. The x represents the input. And so f of x means I'm calling my function f so that I actually could graph different functions. Like if I had all of these y equals and I were to graph them on the same graph grid, it's hard to know which one's which. But if I were to change the names to f of x or g of x, then I can say I've graphed f or I've graphed g on my graph grid. It lets us have more than one function that we compare. The x is your input, and f of x as a whole is talking about your output. Normally, we'd have a y here, so f of x together is talking about your y value or your output. And then on the other side, the 3x plus 4, that's the rule. It's just telling us what do we do with our x's when we plug them in. So we're going to think of functions like a machine where we plug one thing in and we get one thing back out. So f of x from above, we're still going to use f of x equals 3x plus 4. We're going to find f of 2. What this is saying is it's saying find y when x is 2. So find y when x is 2. That's how we read that notation there. So what we're going to do is we're going to say f of 2 is replacing my x value with 2. So if 2 is my input, what I am going to do is I'm going to do 3 times my input plus 4. So since my input is 2, I'm replacing my x value with 2, and I am getting 10 back out. So therefore, f of 2 is 10. What that is saying is when x is 2, y is 10. You're used to seeing it as a coordinate point, x comma y. Now you can see this as function notation. So we're going to go ahead and graph this function. F of x equals 3x plus 4. Notice this is still in slope-intercept form. So we're just going to graph this like we did before. Our y-intercept here is 4. Our slope is 3, meaning I'm going to go up 3 over 1, up 3 right 1, and down 3 left 1. You can still graph functions the same way you graphed your linears, and they were linear functions. So in function notation, it's the same thing. You also can get a graph, and you can say, if this is f of x, I actually can use my graph to help find things. So if I want to say find f of -2, this is saying when x is -2, what is y? So what we can do is we can find the coordinate point where x is -2, and it would be this one over here. X is -2 when y is -2. So when x is -2, my y value was -2. Let's go ahead and try another one. Let's find f of, I don't know, 1. Okay? When x is 1, what is y? So what we can do is we can look at our graph. 1 comma something happens here. So when x is 1, my y value here is 7. So f of 1 is 7. You also can use it backwards. So let's try f of x equals -5. What is x? So in our function notation, f of x, as a reminder, is a fancy way of saying y. So this is saying your y value is -5. What is your x value? So what you can do is you can go to wherever y is -5 and say this coordinate point here is -4, -5. So when y is -5, my x value then is -4. So you can use function notation by reading it like a coordinate point. Let's see how we can use function notation to algebraically solve for things. So notice here I actually have 3 different names of functions. I have f, I have g, and I have h. So we're naming them different things because we have different rules that we are using. So when I look at number 1, it is saying go to f. So I want to make sure I'm using this rule here and plug in 2 for my x value. So I'm going to do 2 times my x value minus 3, but for x, I want to plug in 2. So as I simplify those, I follow my order of operations. So f of 2 is 1. If I plugged in 2, I got 1 back out. That's what that's saying. Let's try this next one. It's g of 2. So the first thing to recognize is I'm going to use my g function, and it's saying take 2 and plug it in for your x value. So I'm going to do x, which is now 2. So I'm doing 2 squared plus 3. So once I do 2 squared, that's 4. So overall, if I took g and I plugged in 2, I got 7 back out. Let's try h of -1 then. H is saying use that third one. So I'm going to do negative x plus 7. And x in this case is -1. So I am doing -1 plus 7. So that's +1 plus 7. So overall, if I plug -1 into h, I would get 8 back out. So this next one, notice how 4, 5, and 6 have that function notation, but they have like a bonus with them. There's something else. So what I want us to do is looking at this one, I want to picture just f of -5. So f of -5, if that were the case by itself, I need to be able to take that and figure out what that is. So I'm going to do 2 times -5 minus 3, because f of -5 by itself would be -13. So what that means is this first part here is saying f of -5, which when I did that, I got 13 for that. So if I do -13 and then plus 7 at the end, that's going to give me -6 in total. So use your function notation and find that first, and then take that answer and do whatever else is with it. So for this next one, what I'm going to do is I'm going to do g of 8. So on the side here, I'm going to do g of 8, and I'm going to figure out what that is first. I'm going to do 8 squared plus 3. So g of 8 is 64 plus 3, or 67. So this problem is saying take that answer of 67 and multiply it by 2. And when you do that, you get 134. So let's try this next one. I want you to take and find h of 5 and h of -7. We're going to do them as separate problems. So h of 5 is -5 plus 7, which is -2. H of -7 is going to be -7 plus 7. So that is 7 plus 7, or 14. So h of 5, we got -2 back out, minus h of -7 was 14. So when we do -2 minus 14, I get -16. So we can use our function notation to evaluate different inputs and outputs and then use those. We also can write things in linear functions using our function notation. So looking at this, what we're going to do, in order to write it in linear function, these ones are going to be in slope-intercept form. So it's going to be f of x equals mx plus b form. This is using function notation. So we need to find our slope and we need to find our y-intercept. So for these ones, we find our slope by looking at our change in y over our change in x. So we look at how our x's are changing compared to how our y's are changing. So for this one, our slope is going to be 6.5. That's how much our y's are changing, when our x's are changing 1. So our slope for this one is 6.5. Then what we can do is we can start in point slope form. So you're going to pick any of your points, and you're going to do y minus y1 equals our slope times x minus x1. And we're going to get this into slope-intercept form. Now, when we get it to slope-intercept form, we have y equals 6.5x. We want this to be in function notation. So instead of writing y, all we're going to do is we're going to change that to be f of x. So you get f of x equals 6.5x. You can always check your answer by taking an input and plugging it in and seeing if you get the same output. So let's try this next one. So let's go ahead and see. From 5 to 1, I'm subtracting 4. From 1 to -3, I'm also subtracting 4. And my x values at the same time are adding 2. So my slope here is going to be how much my y's are changing over how much my x is changing. So change in y over change in x, which is going to be -2. I'm going to start with one of my points. So y minus 5 equals -2, x minus 1. And then I'm going to get this into slope-intercept form. So I get y equals -2x plus 7. And then the last thing is to put this into function notation. We're going to use f of x instead of y. So f of x equals -2x plus 7. Okay, so let's go ahead and take a look at number 8. We have this pizza shop. We want to fill out our table and write our function. So instead of rushing these word problems, I'm actually going to stop the video here, and then I'm going to record another video with just the word problems. So try it and then come back to that other video and then let me know if you do have any other questions.